Okay, let's look at the homework 18, problem 6. All right, so you have a triple integral now, and over the volume, x squared plus y squared is less than or equal to 4. So this is inside a cylinder. So the height is from the xy plane to z equals 5, and v is given here. All right. So it doesn't seem like it's a lot of fun to take the divergence of this and see if we can rewrite this as a double integral using divergence theorem to make our lives a little bit easier. All right. So this is going to be double integral over the surface of this cylinder, right? Then we're going to have to do a v dotted with unit normal, outer normal vector over this surface. All right, so let's do that. First, we need to draw a picture. So this is going to look like this. So here is the y-axis, and here is the x-axis. And here's the z-axis. All right, and it's a cylinder with radius 2, so it's going to look like this. So this is the bottom of the cylinder, and it's going to have a height of 5, so it's going to go up to 5. So I'm going to just draw this picture here. All right, and this is going to be 5 right there, and 0 right there, and 2, 2, negative 2, negative 2. All right, so this is the cylinder. All right, then we're gonna just split into, let's see, top part. So I'm gonna call this guy top. So I'm gonna call it T. Right. And the bottom side, so I guess I'm going to call it the bottom side is B, right? Then you have this lateral side, so this is going to be a side right here. So all around, right? And the back side too. So that's going to be a side, say, S, right? So we need to evaluate the double integral over these 3 kind of separate surfaces. So we have this is going to be a double integral over the top, right? And same thing, v dot n d sigma plus double integral over the bottom. So I'm going to call it b, and v dot n d sigma plus, and double integral over the curved surface f's, and v dot n d sigma. All right, then we notice that here v has only x component and a y component, and no outer normal vector on top is actually just k vector. Right, so this is going to be equal to, so this guy is actually k, right? But k is the 0, 0, 1. So if you take the dot product with v, it's going to be 0 because there's no z component. So this is going to be equal to 0, right? And similarly, the bottom side is the, let's see, the outer normal vector will be negative k, right? So this guy is negative k. And again, this has no z component, so that product is actually 0, right? So we can actually just ignore the first 2 integrals, right? Because they're both 0. Right, so we just have to focus on doing this. All right, so this is going to be all right? So V is, so this is over this lateral surface, and the V is that guy. So x square root of x squared plus y squared, and y square root of x squared plus y squared, right? Then outer normal vector would be this guy right here. Right? How do we find that? So it has to be perpendicular to x squared plus y squared equals 4. So we just take the gradient of this guy. So I'm gonna call this guy right here f. All right, let's find the gradient. Gradient of f is going to be, all right, so that's going to be partial with respect to x is 2x, plus partial with respect to y will be 2y, partial with respect to z is 0, right? Then you can just normalize it or just make it a unit vector. So n is going to be equal to simply x comma y comma 0 divided by square root of length of that x squared plus y squared, right? So we put that in here. So x plus y comma 0, then divide by square root of x squared plus y squared, right? And the first thing is you can cancel. Here's the x squared, square root of x squared plus y squared. Cancel with that, and you're gonna get double integral over s, right? X squared, x times x, so x squared, plus y times y, so y squared, right? D sigma, right? But s is the lateral surface here, so equation is x squared plus y squared is equal to 4. So luckily this guy is always equal to 4, right? So this is going to be 4 times, right, times the area of the surface S, right? Then you know that the area of S, actually I'll let you find the area of S is right here, right? So this, if you cut it open, it's going to be a rectangle, and with the height, which is going to be 5, and the length is just the circumference of this circle. So you should be able to find the area of that. So I'll let you find it. So this is equal to, right? That's it. I hope that this was clear.